Good morning, class. Bonjour, Pilipinas. Before we start our discussion, let us pray virtually. Dear God, Amen. Hello, class. To formally start our discussion, allow me to introduce myself. I am Mr. Carlo Jacob Gumapac. I am your instructor.
So, what is transformer? So, a transformer is a device that transfers electric energy from one alternating current circuit to one or more other circuits, either increasing or stepping up or reducing stepping down the voltage. So, what is the importance of transformer in power supply? So transformers help improve safety and efficiency of power system by raising and lowering voltage levels as and when needed. They are used in a wide range of residential and industrial applications, primarily and perhaps most importantly in the distribution and regulation of power across long distance. So, I have a short video and please watch it. It is all about the transformer.
Let's talk about transformers. Not the machines that transform from cars to combat robots you see in the movies, but the kind you see at the top of utility poles or on the ground in your neighborhood. Transformers are used to step electric voltage up or down before it makes its way to its final destination. Why does this need to happen? Original power distribution voltage can range from 7,200 to 24,900 volts, depending on your electric utility provider's practice, the distance to the furthest member, and the amount of load served. That's much too high a voltage for safe home or business use. Transmission lines connect the power to substations brimming with transformers and control equipment. This is the first place where they transform the voltage to safer, more manageable levels for the distribution system. The voltage then travels through distribution lines, takes one or two more steps down, and arrives at your home. Power feeds into your home's electrical outlets and lights at 120 volts, while water heaters, ranges, and HVAC systems receive 240 volts, both considerably lower than the original voltage. Here's a quick look at how transformers actually work for a typical American home. Transformers start with an iron core. On two sides of this iron core, wire is coiled. On the high voltage side, the coil is wrapped around the core many times. This side receives or produces high voltage. On the other side, the coil is wrapped around fewer times, receiving or producing lower voltage. As the electricity flows through the high voltage coil, it creates a magnetic field that induces a lower voltage in the other coil. That's how the magic of transformation takes place. Transformers are everywhere in our daily lives, not just on your utility provider's lines. Take your cell phone charger, for example. Many of these small cousins of utility transformers perform a similar function. Charging your cell phone with 120 volts will fry it instantly, so the charger converts the voltage to a more tolerable 5 volts or so. The use of electricity touches nearly every aspect of our modern lives, and we have transformers to thank for bringing it safely into our homes.
Types of transformers and its parameters. So first is on the basis of design. First is the core type transformer. This transformer features two horizontal sections with two vertical limbs and a rectangular core with a magnetic circuit, cylindrical coils, or high voltage and low voltage are placed on the central limb of the core type transformer. As you can see in the picture below, that is a core type transformer. It has a laminated core, the low voltage connection, the low voltage winding, the high voltage insulation, high voltage winding, and magnetic lines of flux. Okay. Next is the shell type transformer. shell-type transformer has a tube and has a double magnetic circuit and a central limb with two outer limbs. And as you can see the picture below, it has a primary winding. It has a core, a flux, and a secondary winding. Next is a single-phase transformer. A single-phase transformer has only one set of windings. Separate single-phase units can offer the same results as three-phase transfer when they are externally interconnected. As you can see in the picture below, it has a magnetic core, it has a flux, applied alternating current supply, it has a primary winding, of course, the secondary winding. So, second is the three-phase transformer. Yes, a three-phase transformer has three sets of primary and secondary windings to form a bank of three single-phase transformers. The three-phase transformers is mainly used for generation, transmission, and, of course, distribution of power in industries. So, the third is on the basis of purpose. Step-up transformer. This type is determined by the number of thorns of wire. So if the secondary set has a greater number of thorns than the primary side, it means that the voltage will correspond to that, which forms the base of a step-up transformer. The second is the step-down transformer. This type is typically used for stepping down the level of voltage in the power transmission and distribution network, and its mechanism is the exact opposite of a step-up transformer. So, dira makita nato ang step-down transformer. Duwa ka box siya sa side. Ang sa side nga left side is the primary alternating voltage, and the next side is the output voltage, which is naadira ang secondary alternating and voltage. So, the fourth is on the basis of use. Power transformer, typically used to transmit electricity and has a high rating. Next is distribution transformer. This electrical transformer has a comparatively lower rating and is used to distribute electricity. The third is instrument transformer. This electrical transformer is further subcategorized into current and potential transformers. As you can see in the picture below, the instrument transformer, it has a gas quotient. Of course, it has a high terminal voltage. It has a magnetic core and winding inside the housing. Of course, naadira ang porcelain insulator, and dira sa ubos is naa siya secondary terminal box. Okay. The fifth is on the basis of cooling. First is the self-cooled oil-filled transformers. This type is generally employed in small transformers of up to 3 MVA and is designed to cool itself by the surrounding air flow. So next is the water-cooled oil-filled transformers. This type of electrical transformer employs a heat exchanger to facilitate the transfer of the heat from the oil to the cooling water. The third one is the air-cooled or air blast transformer. In this type of transformer, the heat that is generated is cooled with the help of blowers and fans that force the circulation of air on the windings and the core. Of course, as you can see on the picture below, the first one is the cold the self-cooled oil-filled transformer. The second is the water-cooled oil-filled. And the third one is the air-cooled or air blast. So again, this is your instructor. This is Carlo Jacob Gumapac saying thank you and God bless.